Hey everybody! In this video for one-dimensional kinematics, we're going to be looking at average speed and velocity in the same problem. Okay, so let's hop to it. A person jogs 12 complete laps around a quarter-mile track in a total time of 18.75 minutes. A, calculate the average speed, and B, calculate the average velocity. Okay, so the first thing is, well, how do you find average speed? Okay, so if you watch the previous two videos on average speed, average velocity, you would see that the formula is V with a line across it for average speed. Okay, speed is distance traveled over the change in time. Okay, now here's the thing. They don't directly give us the total distance traveled in the question, but they do tell us that the person jogs 12 complete laps around a quarter-mile track. Okay, so this is how we're going to determine the distance. Okay. So let's do that on the side here. The distance is, well, 12 laps times 0.25 miles per lap. And if you recognize this method, it's just like I told you before, how to convert units. You take what you're given originally and you multiply by 1. Okay, so notice the laps are going to cancel. You're left with the unit of miles. Okay, so 12 times 0.25, or rather a quarter of 12, is 3, so the person runs 3 miles. Okay, so we're going to go ahead and plug that in up here. So 3 miles divided by 18.75 minutes, which is the total time. Okay, we want to convert the miles to meters, and we want to convert the time in minutes to seconds. So we're going to have to do a few little calculations there. Okay, so but first let's simplify. 3 divided by 18.75 is 0.16. So we have miles per minute. Okay, now we're going to multiply that by 1 a few different times. We have to multiply it by 1 actually twice because we have 2 units we're changing. One is the miles, one is the minutes. Okay, let's change the minutes first. So we're going to multiply by 1 as per usual. Okay, we're trying to get rid of minutes, so we write minutes on top. We want to get the unit of seconds because that is the SI unit for time. We put seconds on the bottom. And the ratio of minutes to seconds that equals 1 is this. 1 minute, 60 seconds. Okay. Next, we're trying to get rid of the miles, so let's set up another multiply by 1. Okay. We're trying to get rid of miles, so we put miles on the bottom, and we're trying to get the unit of meters, so we're going to go ahead and put meters on top. Now, if you don't already know this, 1 mile is 1,610 meters. Okay, so there, in fact, our minutes are going to cancel, our miles are going to cancel, and we're left with meters over seconds. Okay. So what this calculation becomes is 0.16 times 1,610 divided by 60. Because if you look at this as a fraction, it's 0.16 over 1. And the way you multiply fractions is you multiply all the numerators across and then you multiply the denominators across. Okay? So 0.16 times 1 times 1,610 is 257. Let me move up a bit. 257.6 meters. 1 times 60 times 1 is 60. Okay. So go ahead, 60 seconds. If you enter that in your calculator, you're going to get 4.29333333 meters per second. Okay, so that's a very high level of accuracy, more than the level of accuracy that we were given in the original question. Okay, so in the original question, here's the thing with these kinds of questions. You've got 4 sig figs here in the time, okay, but you see how you're told 12 complete laps or a quarter mile? These two, the reason they're not given to you in number form is because they're not giving you any level of certainty with that. Okay, so your only value that you can, well, measure your sig figs against is the 18.75, which has 4 sig figs. Okay, so accounting this for 4 sig figs, okay, that means we're only going to the first 4 numbers, okay? Therefore, this becomes 4.293 meters per second. Okay, so that is the answer for part A. That is the average speed. Okay, now moving on to part B. What is the average velocity? Okay, now some of you might be thinking, well, average velocity, that's probably going to be the same calculation, because if you compare, average velocity formula is also v with a line over top. Now the difference is velocity is the displacement over time. So delta d over delta t. Okay, in fact, if you want to be very accurate, displacement is a vector quantity. It should have an arrow on top of it. Okay, now change in displacement over change in time. Now, before I even plug in any numbers, there's something that I have to make absolutely clear. Okay, the person jogs 12 complete laps. So it doesn't really matter how many times they went around. Okay, so let's say this is the track, okay, and the person started here. That means they ran around 12 times. Okay, but the idea here is it doesn't matter how many times they ran around because they always finished where they started. Okay, and the fact that you start and stop in the same position means your displacement is 0 because your final position and your initial position are the same. Okay, so if your displacement is 0, it doesn't matter how much time, right? Because the denominator here can be anything. 0 divided by any number gives you 0. Okay, so therefore the average velocity is 0 meters per second. Okay, so this is actually a really common question to be asked in terms of velocity. You first find the speed by using the total distance and dividing it by the time, but in many cases the velocity becomes 0 because, well, you start and finish in the same spot. Okay, this can be used for a Ferris wheel question. If you go around on the Ferris wheel, what's your average velocity if you start and stop in the same point? Same thing, it's gonna be 0. Okay. So overall, that's it for this video, guys. If you liked it, be sure to subscribe to my channel, give that like button a click, and share this video if you think there's anybody else who can benefit from it. Okay, thank you so much for watching, guys, and I'll see you next time.